The main concern with daisy chaining power strips is the creation of circulating ground loops. When multiple surge protectors are connected in a daisy chain, the chassis or protective ground wires, known as equipment grounding conductors or EGC, are also connected in parallel. This creates a path for current to flow between the ground terminals of the surge protectors, bypassing the intended ground path through the wiring system. This circulating current can flow through the equipment connected to the power strips, potentially creating a safety hazard. Another concern is overloading the circuit. Each power strip has a maximum amperage rating, which is based on the capacity of its wiring and internal components. When multiple power strips are daisy-chained, the total amperage draw can exceed the capacity of the circuit, leading to overloads. Additionally, the combined length of the cores and the internal resistance of the power strips can cause a significant voltage drop, especially if the power strips are carrying a heavy load. This can result in low voltage being delivered to the equipment, which can impair its performance or damage it. The National Electrical Code, or NEC, prohibits daisy chaining power strips in section 110.3. B conductors, including splices, shall be arranged, installed, and connected so that the system voltage shall be kept off the enclosure or outer jacket of equipment except as provided in A. By connecting multiple power strips together, the enclosure or outer jacket of the equipment, that is, the surge protectors, can become energized with the system voltage, which is a violation of this code requirement. To avoid these hazards and ensure safety, it is recommended to use only one power strip per circuit and to avoid daisy chaining them together. If additional power outlets are needed, consider using a multiple outlet adapter, or MOA, that plugs directly into a single wall outlet. A MOA should be Underwriters Laboratories listed and have a maximum amperage rating appropriate for the intended use. Let's delve deeper into each of these aspects. Firstly, circulating ground loops occur when there are multiple paths for ground current to flow. In a properly wired electrical system, all ground connections should radiate from a single point, typically the service entrance. This ensures that any fault current flows directly back to the source, tripping the circuit breaker or fuse and energizing the circuit. However, when power strips are daisy-chained, the ground wires within each power strip create additional parallel paths for ground current. This can lead to a situation where current flows between the ground terminals of the power strips, creating a loop. This circulating current can then induce noise and interference in sensitive electronic equipment, and in some cases, it can even pose a shock hazard. Secondly, overloading a circuit is a common cause of electrical fires. Every electrical circuit is designed to handle a specific amount of current, measured in amps. This limit is determined by the size of the wiring and the rating of the circuit breaker or fuse. When the total current draw of all the devices plugged into a circuit exceeds its capacity, the circuit is considered overloaded. Daisy chaining power strips increases the risk of overloading a circuit because it allows you to plug more devices into a single outlet than it was originally designed to handle. Each power strip has its own maximum amperage rating, but this rating is not a guarantee that the power strip will prevent you from overloading the circuit. It is simply a measure of how much current the power strip itself can safely handle. The actual limit is determined by the circuit breaker or fuse protecting the circuit. To avoid overloading a circuit, it is important to know the amperage rating of the circuit and the total amperage draw of all the devices you plan to plug into it. The amperage rating of the circuit breaker or fuse is typically printed on the device itself. The amperage draw of each device is typically listed on a label on the device or in its user manual. You can then add up the amperage draw of all the devices to determine the total load on the circuit. If the total load exceeds the amperage rating of the circuit, you need to either reduce the number of devices plugged into the circuit or move some of the devices to a different circuit. Thirdly, voltage drop occurs when the voltage at the outlet is lower than the voltage at the service entrance. This can happen when the wiring is too long or too thin, or when there is a heavy load on the circuit. Daisy chaining power strips can exacerbate voltage drop because it increases the length of the wiring and the number of connections in the circuit. The longer the wiring, the greater the resistance to current flow. This resistance causes the voltage to drop along the length of the wire. The more connections there are in the circuit, the more resistance there is overall, and the greater the voltage drop. Voltage drop can cause a variety of problems, including dimming lights, sluggish performance of electronic devices, and overheating of motors. In severe cases, it can even damage equipment. To minimize voltage drop, it is important to use appropriately sized wiring for the length of the circuit and to avoid daisy-chaining power strips. The NEC provides guidelines for determining the appropriate wire size for different circuit lengths and loads. Finally, the NEC violation is a serious concern. Section 110.3 B of the NEC requires that all electrical equipment be installed in accordance with its listing and labeling. This means that you cannot modify or alter the equipment in any way that would violate its intended use. Daisy-chaining power strips violates this requirement because it is not the intended use of the equipment. Power strips are designed to be plugged directly into a wall outlet, not into another power strip. When you daisy-chain power strips, you are creating a potential safety hazard because you are exceeding the equipment's intended limitations. In addition to the specific concerns mentioned above, there are also some general safety precautions that you should always follow when using power strips. Firstly, never use a power strip in a wet or damp location. Water is a good conductor of electricity, and it can create a shock hazard if it comes into contact with electrical equipment. Secondly, never cover a power strip with anything. Covering a power strip can trap heat and cause it to overheat, which can lead to a fire. Thirdly, inspect power strips regularly for damage. If you see any cracks, frayed wires, or other signs of damage, replace the power strip immediately. Fourthly, do not exceed the power strip's maximum load rating. This rating is typically printed on a label on a power strip. Overloading a power strip can cause it to overheat and potentially start a fire. Fifthly, plug power strips directly into a wall outlet, not into an extension cord or another power strip. Using an extension cord or another power strip can create a fire hazard. Sixthly, make sure the power strip is Underwriters Laboratories listed. Underwriters Laboratories is a testing laboratory that certifies electrical products for safety. A Underwriters Laboratories listed power strip has been tested and found to meet certain safety standards. Using a non-Underwriters Laboratories listed power strip can increase your risk of electrical shock or a fire. Multiple outlet adapters, or MOAs, can be a safer alternative to daisy-chaining power strips if you need to plug more devices into a single outlet. MOA are designed to plug directly into a wall outlet and provide multiple outlets. They are typically Underwriters Laboratories listed and have a maximum amperage rating appropriate for the intended use. However, it is still important to avoid overloading the circuit when using an MOA. Make sure to calculate the total amperage draw of all the devices you plan to plug into the MOA and ensure that it does not exceed the amperage rating of the circuit. In summary, daisy-chaining power strips is a dangerous practice that can lead to a variety of safety hazards. It is important to avoid this practice and to use only one power strip per circuit. If you need additional outlets, consider using a multiple outlet adapter that plugs directly into a single wall outlet. Always follow the safety precautions mentioned above when using power strips or MOA. By taking these precautions, you can help to prevent electrical shock and fire. Let us consider some additional details about ground loops and their impact. A ground loop is formed when two or more points in an electrical system that are supposed to be at the same ground potential have a potential difference between them. This potential difference can cause current to flow through the ground conductors, creating a loop. This circulating current can then induce noise and interference in sensitive electronic equipment, and in some cases, it can even pose a shock hazard. Ground loops are often caused by improper grounding practices, such as connecting multiple ground points together in a way that creates a loop. They can also be caused by differences in ground potential between different buildings or even different parts of the same building. The effects of ground loops can range from minor annoyances, such as humming audio equipment, to serious safety hazards, such as electrical shock. In some cases, ground loops can even damage equipment. There are several ways to prevent ground loops. Firstly, ensure that all ground connections radiate from a single point, typically the service entrance. This prevents the creation of multiple ground paths that can form a loop. Secondly, use shielded cables to protect sensitive electronic equipment from noise and interference caused by ground loops. Shielded cables have a conductive layer that surrounds the signal conductors and is connected to ground. This shield helps to block electromagnetic interference and prevent it from inducing current in the signal conductors. Thirdly, use isolation transformers to isolate different parts of the electrical system from each other. Isolation transformers have separate primary and secondary windings that are electrically isolated from each other. This prevents ground loops from forming between the different parts of the system. Fourthly, use ground loop isolators to break the ground loop. Ground loop isolators are devices that are inserted into the ground path to break the loop and prevent current from flowing. These are often used in audio and video systems to eliminate hum and noise caused by ground loops. Now let's consider the issue of voltage drop in more detail. As previously mentioned, voltage drop occurs when the voltage at the outlet is lower than the voltage at the service entrance. This is due to the resistance of the wiring, which causes the voltage to drop along the length of the wire. The amount of voltage drop depends on several factors, including the length of the wiring, the size of the wiring, the amount of current flowing through the wiring, and the temperature of the wiring. Longer wiring, smaller wiring, higher current, and higher temperature all contribute to greater voltage drop. Voltage drop can have a number of negative effects on electrical equipment. Firstly, it can cause lights to dim. This is because the light output of incandescent light bulbs is very sensitive to voltage. Even a small drop in voltage can cause a significant decrease in light output. Secondly, it can cause motors to run slower and less efficiently. Motors require a certain voltage to operate properly. If the voltage is too low, the motor will not be able to produce its rated power, and it will run slower and less efficiently. Thirdly, it can cause electronic equipment to malfunction. Electronic equipment is designed to operate within a certain voltage range. If the voltage is outside of this range, the equipment may malfunction or even be damaged. Fourthly, it can cause heating elements to produce less heat. Heating elements, such as those found in electric heaters and ovens, produce heat by passing current through a resistive element. The amount of heat produced is proportional to the square of the voltage. Therefore, even a small drop in voltage can cause a significant decrease in heat output. The NEC provides guidelines for minimizing voltage drop in electrical systems. These guidelines include recommendations for wire size, circuit length, and load. In general, it is important to use appropriately sized wiring for the length of the circuit and to avoid overloading the circuit. In addition to the NEC guidelines, there are also some other things you can do to minimize voltage drop. Firstly, use copper wiring instead of aluminum wiring. Copper has a lower resistance than aluminum, so it will result in less voltage drop. Secondly, use shorter wiring runs whenever possible. The shorter the wiring run, the less voltage drop there will be. Thirdly, use dedicated circuits for high current loads. This will prevent the high current load from causing voltage drop on other circuits. Fourthly, use voltage regulators to stabilize the voltage. Voltage regulators are devices that maintain a constant output voltage regardless of changes in the input voltage. They can be used to compensate for voltage drop and ensure that equipment receives the correct voltage. Finally, let's consider the different types of power strips and their features. There are many different types of power strips available, ranging from basic models with just a few outlets to more advanced models with surge protection, overload protection, and other features. Basic power strips typically consist of a strip of outlets connected to a power cord. They provide a convenient way to plug multiple devices into a single outlet, but they do not offer any protection against surges or overloads. Surge protectors are power strips that include circuitry to protect against voltage surges. Voltage surges are sudden spikes in voltage that can damage electronic equipment. Surge protectors work by diverting the excess voltage to ground, protecting the equipment from damage. Overload protectors are power strips that include a circuit breaker or fuse to protect against overloads. Overloads occur when the total current draw of all the devices plugged into the power strip exceeds its capacity. Overload protectors work by tripping the circuit breaker or blowing the fuse, cutting off the power to the power strip and preventing damage. Some power strips also include other features, such as USB charging ports, Ethernet ports, and cable management systems. USB charging ports allow you to charge USB devices, such as smartphones and tablets, directly from the power strip. Ethernet ports allow you to connect devices to the internet through the power strip. Cable management systems help to keep cords organized and prevent them from becoming tangled. When choosing a power strip, it is important to consider your needs and select a model with the features that are most important to you. If you live in an area with frequent power surges, a surge protector is a must. If you plan to plug in a lot of devices, an overload protector is also important. And if you want to be able to charge USB devices or connect to the internet, look for a power strip with those features. It is also important to choose a power strip that is Underwriters Laboratories listed. This means that the power strip has been tested and found to meet certain safety standards. Using a non-Underwriters Laboratories listed power strip can increase your risk of electrical shock or fire. Remember, electrical safety is paramount. By understanding the risks associated with daisy chaining power strips, taking preventive measures, and using appropriate electrical equipment, you can help protect yourself and your property from electrical hazards. When in doubt, always consult a qualified electrician.